Jai Hind everyone. So in today's lecture, we will be going to study about fundamentals of mathematical logic, the propositions and the predicates. So let's start. Now the question arises, what is a logic? So basically the logic is that area of mathematical science, and you can say it is also known as mathematics of reasoning, and the very first study that was taken up by the Greek philosopher Aristotle. So the language, which is known as prologue, is built basically upon the foundation of logic. So the word prologue is, it is an abbreviation for the programming in logic. So the logic is used in natural language processing theorem. So basically it is used for, proving theorems, then proving the game theory, then automatic answering systems, then, control systems, graphical user interfaces, ontologies, and so on. So basically you are using logic into these particular applications. So you are using that particular science to prove that theorems, to calculate that particular theory, or to find out the various answers of these particular things. Now, what do you mean by the logic and what are the various types? So we have already studied that what is logic. Now what are its types? So there are two types of logic. So number one is your symbolic logic and the second one is your first order predicate logic. So what is symbolic logic? So symbolic logic is a kind of a logic in which we deal with the declarative sentences. So what is declarative sentences here? That you have to declare something, that I just want to say that I am going to school and my friend is also accompanying me. So this is a kind of a declaration that I am saying something, I am declarative, I am declaring something that this is the thing that is going to happen or it is going on. So basically the symbolic logic is kind of the logic which deals with the declarative sentences. So the meaning of these sentences can be modified with the use of the words like not, and, or, if, then, and if and only if, exclusive or, and so on. So basically you are using these kinds of connectivities or the connectives in order to make a sentence which will be known as declarative sentences. So these words are also called as the statement connectives. What are those words? That are not, and, or, if, then. If then is like, if it is raining, then there must be clouds. So these are the kinds of the statement connectives. Okay. So the declarative statements which are true or false. Okay. The declarative statements which are true or false, but not both. Mind these words. These could be true or false. That could not be both. Like this is like, if it is raining, so it could be a true or it could be a false. It could not be like it is raining and it is not raining. So there could not be both. These are only known as propositions. So let's take an examples for the statements that may be clear you about the propositions. So the number one example is 2 is not a prime number. So this is a kind of a declarative statement, and you can say this particular statement either be true or false. So 2 is not a prime number. This is a declarative statement. The next example is 6 is a composite number. So 6 is a composite number. Again, this is a declarative statement. Either it could be true or false, cannot be both. So these two are the propositions. Okay, in the last slide, I have already mentioned the declarative statements which are true or false, but not both. These are known as propositions. The third example is some of the compound statements are. So this is also a kind of a declarative statement, but this is not a proper proposition because this is not having a kind of a, you can say the solution which would be giving you the answer in a kind of a true or a false statement. Some of the compound statements are. So the statements that are going to be followed after this statement, these could be true or could be false. So this is a dicey situation. This we cannot say that this is a kind of a proposition. The next example is 2 is prime and 6 is a composite number. So here 2 is prime, this is a declarative statement, and here is your connective, and 6 is a composite number. So here in this example, you are combining two sentences or two statements with the help of the and connective. And it could be true, it could be false, because you are merging two sentences. So after merging, the result would be either true or false. That's why this is known as the proposition. So the next example is, if 2 is not prime, then 6 is a composite number. So in this particular example also, there is a declarative statement with the connectives what? If, then. So in the last slide, I have already told you that connectives are like and, or, if, then, if and only if. So here, if, then is the connective, and the 2 is not prime and 6 is a composite number, that is a declarative statement. In the next example, if 2 is not a prime, if and only if 6 is a composite number. So again, we are using a kind of a connective here, that is if and only if, and I am combining two statements, that is 2 is not a prime and 6 is a composite number. So what I am going to do, I am going to merge these two statements into one statement, and I am getting the result either in a true form or in a false form, or you can say this could be a tautology or a fallacy. So here 2 is not a prime if and only if 6 is a composition or a composite number. So this is also a kind of a proposition. The next example is 2 is prime or 6 is a composite number. So here in this particular statement, or, the word or is connective. So as we have already seen in this particular example, the and here is the connective, and in this example or is the connective. The next example is, the and connective is also called the conjunction operation, and the or operation is also called as the disjunctive operation. So there is a word for this particular connectives. If you are using and connective, then you can say you are using the conjunction operation. And if you are using the or operation, then you can say you are using the disjunction operation. Now, what are the symbols used for these connectives? When we are playing with all these sentences, then we have to use some connectives. So there must be, you are actually reducing these English statements into a kind of a mathematical form. So when you are reducing these statements, you have to use some kind of letters or connectives or symbols or whatever not. So in this particular slide, we will be going to use these particular symbols for reducing a particular statement into a mathematical form. So here the and connectives is denoted by this particular symbol. Okay, so if I am saying Ram and Shyam, so if I am taking Ram, suppose P is representing Ram, okay, and Q is representing Shyam, S-H-Y-A-M, okay. So if I am saying Ram and Shyam are going to school, so how I am able to write this? Ram and Shyam are going to school. So if I am saying P, Q, that is P representing Ram, Q representing Shyam, and there is a connective and. So Ram and Shyam. Now how I am going to connect these two particular sentences with the help of and operator, which could be written as like this. So this is Ram and Shyam. So this is the denotation of your and connective. Okay. Or connective will be represented as this. This you can say a small v. So or is represented by small v. If you encounter if then, like if there is cloud, then there will be raining. So that particular statement is having a kind of a connection which is using two words if and then. So if there is a particular statement which is using if and then that would be represented by this particular connective arrow diagram or a arrow only. If you are using if and only if as a connective, your sentence is having if and only if, then there is a double side arrow. That is the representation of if and only if. If you are using exclusive or, then exclusive or will be used by this particular symbol. Okay, and this is used for not. You can say not can be used by this particular symbol, negation, like it is not Ram. He is not Ram. So he is not Ram. If P is representing Ram, then not Ram will be negation of P. This is negation. Or you can easily write it as like this. This is also negation. Fine. So this is used for not. Now these particular symbols are used for the connectives. When we are expressing some statements, then when we are deducing that statements into mathematical form, then these symbols will be used. So all proposition are assertion, but vice versa is always true, is not always true. Yes, whatever the propositions that you are taking with, that could be assertions, but all assertion would not be propositions. So we have to make sure that whatever the statement that we are dealing with, that should be a proposition. That should not be a kind of you can say that should not be the sentence which is not able to deduce in the mathematical form. So we need to work upon that also. So in this sentence, this particular sentence, the pot is hot or cold. So it is, it is using the connector because it is using or here. The or connective is here, and obviously what you are saying in this particular sentence, the pot is hot or cold. So either it could be true or it could be false, because you are not actually saying something which would be having a kind of a statement in a one form only. Either it could be true or it could be false. The pot is hot or it could be cold. So you are using the or connective here. The or is used in the exclusive sense. Why it is an exclusive sense? Because either it could be true or it could be false. So that's why the pot is hot or cold. Fine. Let's take some another examples in which we will be dealing with, we will be deducing these particular statements into the mathematical form or the logical form. So I go to school or it is raining today. If I want to deduce this particular sentence, then how I am going to write it? So I go to school. If I am going to say that I go to school will be represented by P, then P is representing what? P is representing I go to school, or it is raining today. So, or Q will be representing rain. So, I go to school or it is raining today. This is like this. You can deduce this particular statement like this. If Mary dances well, the Peter is 6 feet tall. So this is if then statement. It is like you are saying if this is, then this is going to happen. So if Mary dances well, then only Peter is 6 feet tall. So if Mary is representing, like if you are saying M is representing for Mary dances well, then what the symbol which will be going to use here is if then. For if then we are using this symbol. So if Mary dances well implies, this is also known as implication, implies or tends to, whatever you want to say. If Mary dances well, then the Peter is 6 feet tall. So if Peter is 6 feet tall can be represented as P, then it would be like M tends to P or M implies P. Fine. Let's take this in this way. I go to school or it is raining today. So I go to school, I am taking I go to school as T. Here the T is representing your I go to school. The next is the sun is shining. In the previous example, we will having another examples here. So this is the particular kind of a form that we are dealing in this particular section. So I go to school is represented like T. The sun is shining could be represented as S. Peter is 6 feet tall could be represented as P. Mary dances well. M is it is raining today. R it is snowing today. I. So these were the examples. I go to school or it is raining. So if I go to school is by T, or is for the, this is the symbol for that is used for or, and R that is raining today. Okay. The next, if Mary dances well, then Peter is 6 feet tall. So in this particular question, what we are doing? We are using the connector which is used for if and then. So if and then we will be using implication. This is the implication. Or you can write it like this also. This is also same. So if Mary dances well, then Peter is 6 feet tall. So M is for Mary dances well, implies Peter is 6 feet tall. Okay. The next, Mary dances well if and only if Peter is 6 feet tall. So we are here using the connectives if and only if. Now if and only if is represented by double side arrow like this way, or you can say, you can also use this kind of representation. This is also same. These and these are same. Okay, so if Mary dances well implies Peter is 6 feet tall. This is also known as biconditional. You can say biconditional or double condition. I do not go to school. So for going to school, I have represented T, and do not go to school, it means I use negation here, not word. So here I do not go to school will be written as negation of T. Fine, or not T. It is raining or it is snowing today. So it is raining. So it is raining is represented as R, and it is snowing is represented as I. So it is raining or, the connective here is or. So how it could be written here? R or I. Fine. So these are the truth tables for or and operation. What happens is when you deduce your sentence into kind of these logics, then you have to find out the truth tables of this particular whatever the logic that you have made, because with the help of the truth table you are able to find out whether that particular statement is a valid statement or a not. So valid statement or the validity of the statement is totally dependent upon the product that you are going to have in your last column. This is like this is like this. This is your output. Okay, I go to school or it is raining today. This is the final sentence. So you have to find out the answer for this particular output, particular logic. So for finding out the solution, finding out the answer, you have to create a table. And how you are going to create a table, that will be shown up here. So this is the truth table for OR operation when you are using the OR operation, and this is for the AND operation. You have to see the operations very well, and you have to, you can summarize this particular operation also. So this is like whenever we are, whenever we are walking into the mathematical logic and we are using various kinds of variables, and when especially we are using only two variables, this is like 2 raised to the power. Okay. So if I am dealing with two variable only, if I am having only two variable in my logic, this is like T or R. There are two variables only, T and R. So whenever you are having only two particular variables, then in that case, your, you can say your rows would be totally dependent upon how many kinds of variables you have. So this is like 2 raised to the power 2. That is 4. It means you will be having only 4 rows for that 2 variables. If you are having 3 variables, this could be like this. P tends to Q or R. So this particular logic is having 3 variables here. So for 3 variables, you have to prepare a truth table in the form of 2 raised to the power 3, that is 8. Okay, so in this particular variable section in which you are having 3 variables, you will be designing a truth table in the form of which is having 8 particular rows. Okay, so this is the form of you are having 2 variables P, Q, and you are operating on OR operation. So what happens is you are taking 2 false statement, two true statements, and then you are taking 1 false statement, 1 true statement, then 1 false, then 1 true. So this is like you are combining all the possibilities that could be happening with that particular statement. If it is this, then this is going to happen, or if it is this, then that will be going to happen. So whatever the possibilities that you can deal with, you are actually considering all these here. So you are taking 2 false, 2 true, 1 false, 1 true, and so on. So what happens in the OR statement is, for every false OR statement, if you are encountering one true at a time. Remember, if you are encountering one true at a time, then your output would be true. So only for OR particular operation, if you are operating one true, you are having one true, at least one true, then your output would be true. Otherwise, other case would be both your variables will be at false. Then your output would be at false. Okay, so let's take, this is like in the second row also, there is F false and the second Q, the variable Q is having the value T. So at least you are having one true here, one T. T is for true, F is for false. So when you are having only one, at least one T, then your output would be T, true. And if I'm talking about if you are operating with the AND operation, then that is totally a opposite case. In that case, you must be having both T for creating a true statement. So you must be having your every variable at true value. So here P is also true and Q is also true. That's why the output would be here is true. For other cases, false, false, that is false, false, true, that is also false, true, false, also false. Fine. Now, this is the truth table for implication and double implication, or I can say if then and. This is for if then. Okay, and this is for if and only if. So this is for if then and this is for if and only if, or you can say implication and double implication or biconditional. So in this particular truth table, what happens is for if then, P implies Q. Whatsoever is your chances or is your probabilities, if you are encountering TF, and that should be also in this order only, that you are encountering true first and then you are encountering false first. Okay, then only you will be having false in your output. Otherwise, all of the possibilities will be having true to its true as its conclusion. So in this particular section, F is also having T as its conclusion. False and true also having true as its conclusion. True, definitely having true as its conclusion, but only for the case TF. So whenever you are encountering TF, true and false, then only you will be having false as the conclusion. So in this biconditional statement, what happens is, if you are having, biconditional statement, false, false, that is also true. Now what happens is, whenever you are having your P and Q same, it means the values of P and Q variables are same. That could be false or that could be true. Then only you are having your conclusion as true. Otherwise, your conclusion would be false. So it means if you are having false and false here, then only your output would be T. In this case, there is also input T and the value of Q is also T, then only you will be having your output T. Otherwise, for F and T, the rate or the value is F, and for T and F also the value is F. Now let's solve an example. Okay, so in this particular examples, like we were dealing before, T or R, like it is I am going to school or it is raining today. So T or R, if I want to create a truth table for T or R, what would be the truth table here? So I will making a table and I am writing T, I am writing R, and I am writing this logic that I have already deduced from this particular statement. So this is your T or R. Okay, now there are only two variables here. So for the two variables, we know how much rows we will be dealing with, 4 rows. Then we will be having 4 options only. So for T, I am writing it's like T, F, F. Okay. And then for the R, I am writing T, F, T, F. Fine. So these are the possible outcomes that could happen with this particular statement. Now for OR, the operation OR says, what does it says? That for every t that you are encountering, your output would be t. Okay. So for tt, the output would be 3. For tf, the output would be t. For ft, the output would be t. But for ff, that is false and false, the output would be f. So here this is the output for this particular expression. Okay, let's take another example. Suppose this one, Mary dances well if and only if Peter is 6 feet tall. So what happened in this particular statement is, you are having M, if and only if, biconditional P. So if I want to create the truth table for this particular statement, also this is having 2 variables. So we are dealing with 4 possible cases here. So I am preparing a truth table in which there are only 4 possible cases. So this is like M, P, M, biconditional P. Fine. So what would be the possible cases here? This is T, T, F, F, T, F, T, F. So these are the possible cases that could happen with this particular sentence. Now what would be the output? So for the biconditional, we know that only for the same you can say condition, only for the same expression, that is T and T, we will be having the output as false. Look at this particular truth table. For only the T will be only on when you are having the same conditions like FF, TT. Then only you are having T. Otherwise, for every other option, it would be a fallacy. So here in this particular example, TT will be giving you T, TF will be giving you false, FT will be again giving you false, and FF will be giving you T. So this is the output for this particular sentence. Now let's take another example for negation T. What would be the value of negation T or the truth table for negation T? So we will be we will be making here whether for the negation T. Suppose this is P or this is T. You can say this is T. I have changed the variable from P to T here. So these are the values of my T now. And I want to calculate the negation of this T. So negation of this T here is, let's suppose I am calculating here. Okay, so this is negation T. So negation T is not T. So whatever the possible value, that will be changed into the negative form. So F will be converted into the negative form. So what would be the negative form of false? That is true. Okay. So this is like reciprocating your value. So F will be converted into T. Again F will be converted into T. Now T will be again converted into F. And again T will be converted into F. Fine. So this is the negation value. Now suppose if you are having a kind of an example in which this is written like P and Q and there is a negation outside this particular expression. So this is like if P and Q. Suppose I go to school and it is raining. And this particular statement is having not in front of it. This is like this. Okay, so that will be calculated by this particular same method. Okay, thank you.